any of what I have on the board. You don't have anything else in your paper. But on your 4-step in front of you, we have included both Z and T. So like we don't need to make another one. So plan for T distribution. What's our first part of plan? Method. So how is it going to be different today, writing method, than yesterday? Friday. It is a one sample T, and so now when we draw the arrow to, don't write anything. So now what do you think we're going to put there? Is random going to change? Are options for normal going to change? Is independent going to change? No. When we write our equation for confidence interval, we actually wrote this on the 4-step. It's going to be x bar plus or minus. And then what goes here? And that's the only thing that changes from Friday to today, other than knowing how to find our T, which is what we just did. All right, so first problem, when 10 cars of a new model, well, this is our what? Were randomly tested for gas mileage. The results showed a mean of, so that's our what? 27.2 miles per gallon with a standard deviation of, so this is my, and we talked about this a little bit on Friday. This is my sample. This is my mean and standard deviation that go with that sample, and that's why I know this is X bar and S and not U and sigma. So what is a 95% confidence interval for the gas mileage achieved by this model? Assume that the population is approximately normally distributed.
Can you say the part about knowing the difference again?
This is our sample size.
Yeah.
This is our mean and our standard deviation for that sample size. And so that's why I know that's sample mean and sample standard deviation.
Because if it was for population,
it would say something. It would definitely not connect it to this.
But it wouldn't be S, it'd be sigma.
Right.
And would it still be S? It'd be mean.
In a different chapter, it's going to give you both, and that's why I'm starting to comprehend.
Okay.
All right, so state. Where do we start there?
We want to estimate.
Which is the
True mean gas mileage of this specific new model.
This is the 12 one.
which way did you say it? This
Specifically modeled car.
specific model car. And then how do I finish that?
With 95% confidence.
So nothing in state changes from Friday. Alright, plan. I could copy this over. What's our first part of plan? And we know this method is going to be a which critical value am I choosing?
T.
Why am I choosing T? and then interval for means. What's our first condition to check? What do I write here? Usually I say stated. What does this one actually state? Is that random assignment or random selection? Did we assign them to do a treatment? So it will get very obvious when we switch. Almost always for right now, they're going to be random selection. Yeah.
It's not stated. How should we prove random?
If it were not stated, then you would have to just say not stated. We can't generalize the results. And you could actually continue. You couldn't expand it to anything. And sometimes that'll happen because I'll forget right word right there. And so what happens in the real world is when they do a preliminary study, they're probably not going to do random to see if it's worth it. And then so their results can't generalize, but their results are going to be like, okay, it's worth this to go into a study to then randomly assign. So that's a lot of times that part isn't included in this one. What's my next condition? What did this one say?
Assuming population for new child analysis is not completely distributed.
So population, I'm just going to write given population distribution. That's the way we usually write it. Even though it said population of miles per gallon results for all this, that's fine. Given the population distribution is approximately normally distributed. So what? What's last? An independent, which is 10% condition. Capital N greater than or equal to 10, lowercase n. What is our lowercase n here?
I just want to double check. Is it like the method thing? Is it T star since sigma is unknown because we know standard deviation is the same?
So this is always the better one. So if this isn't if I don't have this, then I have to go to my second option, which is S.
Because we have standard deviation.
Right.
It would be
It's just we don't
sigma
know right. We know S, not sigma.
because sigma would be the whole thing,
Mhm.
not the.
Alright, so what would I write here with there are at least 100? There are at least 100 what?
Cards within the model.
Cars of, I like the way we said it earlier. I'm going to go with the same way that I say here.
Specific model.
Cars of specific new model. I always talk about trying to keep it the same, and I always say I do it because it's easier to just copy it over. It's also good because if you mess up the first time, and then you reword it the second time, so now you're going to get counted off for not doing it correctly, and then you get counted off again for not matching. So like if you do something wrong and keep it wrong for the whole page, you get docked once. if you do it wrong and then switch it, you might get docked twice. So that's another big reason for keeping it consistent. There, you got everything here, right? So the only thing that changed on this whole page was that we wrote T and sigma's unknown. What's the first thing I need? Which is what else? Which is what else for my sample? And our N was what else does the problem give me? And I always go ahead and write degrees of freedom also with that so that I don't accidentally use 10. And then what's the thing I'm going to find to put right here? So on my T paper, I'm going to 95% on the bottom. I'm going to degrees of freedom of 9 on the left side. And I get what? This is another reason why I always keep my Z's to 2 and my T's to 3 is just to differentiate between the two, but there are going to be those 2.756 and 1.645 that I end up writing the 3 decimals instead, which doesn't really matter. All right, so with my general equation with no numbers plugged in,
X dot plus or minus times S over square root of.
and then I just plug in my numbers, 27.2 plus minus 2.262, 1.8 over square root 10. What's still going to be my symbol in the middle? And this problem was miles per gallon also. I don't have this one in front of me without, well, I guess I could go look it up. And what do you get as your lower bound? And an upper bound of 4876. So where does my conclude start? I'm just going to go ahead and start writing. I think some of y'all are writing. I'll go ahead and type it out. We are 95% confident that mu, the true mean, I'll write the same way I wrote it before, gas mileage of a specific new model car. And falls between What is our equation that we used on the homework? What is our equation that we used on the homework for finding minimum sample size with means?
N is greater than or equal to z times standard deviation divided by margin of error squared.
Alright, so let's think about through this of using this with t. Well, obviously if we use t, that would be a t instead of z. Obviously if we use t, that would be a what instead? But what do I need to be able to find a z-score? What do I need to find z star? Confidence. What do I need to find t star? And how do you find degrees of freedom? So if we're trying to solve for n, would it ever make sense to plug in a t there? I'm always going to have some people who try to do it and get confused. You should never use this equation with t because you literally can't get there. You need n to find it, so we can't be solving for n using something that you needed n to find. So you would always use z there, never t.